Hello everyone and welcome to this talk. My name is Nuruddin Sadawi, and in this presentation I'm going to be introducing a method for the automatic identification of COVID-19 from just a cough sound of people using artificial intelligence. This is in contribution to the Libyan International Forum for Information Technology happening in Tripoli, Libya in December 2020. Before I begin the talk, I wanted to quickly introduce myself. I have a PhD in computer science from the University of Birmingham. I specialize in machine learning, and at the bottom there, as you can see, I've provided two short URLs for the current list of my publications and my own YouTube channel. So I wanted to begin the talk by telling you that this method can be actually more accurate than the human diagnosis, and in the talk we'll find out why. So تشخيص الإصابة بفيروس كورونا من صوت الكحة identify COVID-19 from cough sound, which can be more accurate than the human diagnosis. Before we begin the technical details though, let's talk about the human voice. And this is something not new to us human beings. We know in general that when somebody is unwell, their voice changes. So we know if someone has maybe a sore throat or they have some viral infection and so on and so forth, their voice or the human voice can be used as an indicator to the health status in general. And this is something really interesting. So in general, our voices say a lot about our health if, of course, we just listen to them. Here I have a confirmation from a professor at the University of Michigan who specializes in vocal health. He says changes in a person's voice can actually indicate anything from a common cold or acid reflux to throat cancer or vocal cord paralysis. This is really interesting, and at the bottom there I provide a link to a nice article that contains interesting findings, and I really encourage you to follow the link or maybe type it in and read the article. It's really interesting. So because this method relies on artificial intelligence, which is in many cases, which depends in many cases on machine learning, I wanted to define what machine learning is. So machine learning is generally the field that focuses on enabling machines, for example computers or handheld devices, to automatically learn and improve from experience without being explicitly programmed to do so. So the machines can learn from experience without manual intervention, and this is normally achieved via algorithms. So there's plenty of algorithms out there that can help you learn, or that can help the machine learn from experience or from data. Usually the purpose is done to explain the past, meaning if we have some data from the past and we want to explain whatever we have in there, extract some patterns and extract some useful information and so on and so forth, or to predict the future, meaning to make future predictions or forecasts and try to anticipate what's going to happen based on the data or based on the experience that was passed to the algorithm. There are different fields and branches of machine learning. You can do classification if you want to predict a category, or you can do regression if you want to predict a real value number, or you can do what we call clustering or grouping, and you can do reinforcement learning where you learn from the environment around you. So this is something, for example, heavily implemented and heavily employed in self-driving cars and so on and so forth. One of these algorithms is the artificial neural networks. So I mentioned in machine learning we have multiple algorithms that they grow by the day. Really, there's a large number of them and they keep growing. One of these algorithms is artificial neural networks, or ANNs, and this is the core of deep learning. So just in case somebody is wondering what deep learning is, it's basically big artificial neural networks. ANNs are inspired by the structure and function of the human brain. So the human brain contains a large number of neural cells that communicate with each other. No one really knows, no human being really knows exactly how the brain works, but these are efforts to mimic the process of the brain, and some of them are really successful to a high extent. So these artificial neural networks saw big progress and huge advancements of the last few years because of hardware progress. So we have much more powerful hardware now. We have GPUs, we have more powerful CPUs, and now we have TPUs, so very powerful CPUs. The memory has grown much more than before. Even disk storage is much cheaper than before, and so on and so forth. And over the last few years, many powerful architectures have been invented. So just to repeat, deep learning is really basically large ANNs, so very deep, meaning artificial neural networks with multiple layers and different fancy and powerful architecture. So one of the powerful aspects of deep learning is the fact that it automatically learns useful features from input data. So normally in machine learning, we do what we call feature extraction or feature generation or feature engineering, where we try to generate some features and then feed them into a model or into an algorithm, and the algorithm learns from those features. With artificial neural networks in general, and especially the deep learning techniques, these techniques learn from the raw data. So you can pass them the data as is, for example, if you have an image or text, and then they can automatically extract features and learn those features so that they can help them in making decisions and making future predictions and so on and so forth. So these features can be used for categorization of the input and many other tasks, for example, such as predicting a real number or groupings and clustering of data points. Artificial intelligence is the field that focuses on enabling machines to learn. So we'd like to give machines the ability to learn, to reason, and to make decisions, basically to automatically act according to the environment around them. So in other words, we want to enable the machines to make their own decisions when they face new situations. This is similar to what human beings do. For example, you teach a child to stay away from fire, stay away from oncoming cars, and so on and so forth, to stay away from danger in general. And then at some point, they will face a new situation that they haven't seen before, but they have the ability now to recognize that that situation is dangerous and they want to stay away from that. That's what we mean by you learn from experience. And we mentioned machine learning and deep learning. Machine learning and deep learning are ways to achieve AI. So if you look at the diagrams here, artificial intelligence is a big field. One way of achieving AI is to do machine learning in general or to use deep learning techniques to be more specific. Now, back to the human voice. The idea here is that we'd like to use the cough sound and just the cough sound to accurately identify people with COVID-19, to be able to tell if a person has COVID-19 or not. And this is really interesting. I mentioned in the beginning that this can be more accurate than the human diagnosis. This is because of the fact that the human ear cannot distinguish the difference in the cough sound of someone who has COVID-19, especially if that person was asymptomatic. An asymptomatic person is a person who has the virus but is not showing or producing any symptoms. So especially if someone is a symptomatic COVID patient, meaning they have the virus maybe but they don't show any symptoms, the human ear cannot really recognize or differentiate the difference in the cough sound, whereas AI algorithms can do that, as we will explain. And this is a crucial difference. And here I provide a link so you can type in this link again to an interview with an expert who actually confirms this fact. I'll speak about this expert later on. And I wanted to basically summarize the technique at a high level. So this is a very high level overview of the technique that you can use. Anyone can develop this with some experience. The first step would be to capture cough sounds. So to maybe record the cough sounds of as many people as possible, and then use advanced techniques, for example, from audio signal processing to extract features. I'll explain this a little bit in the coming slide. Once you've done that, and of course what you want to do is collect cough sounds from people who have COVID and people who don't have COVID. So you have healthy people, no COVID, and then people with the virus. After you've done this and after you've generated or extracted the features, you can create what we call a binary classification data set of those feature values. So basically for each individual, we'll call an individual now a data point. Each individual now you have all the features and then you have their category, i.e. COVID or non-COVID. So negative or positive or negative. It depends on the way you want to do it. Once you've created that data set, you can train a deep learning model on that data, or maybe you can use an existing model, a pre-trained model. This is what we call transfer learning on that data set, and you can evaluate your model, you can test it, you can make sure it performs well. After that, after the model now is ready, you can use it for future predictions. So you can employ the model in what we call production. You can host it, for example, on the cloud, and then you can send cough sounds to it, and then it'll get back to you. It'll respond by sending you the diagnosis, COVID or non-COVID. This is a high-level overview. And to speak a little bit more about extracting features from audio signals, this is normally the first step in any automatic speech recognition system. If you may have seen things like, for example, transcription tools where you speak to the tool, you speak to the computer, and then the computer writes down what you're saying. This is a way of transforming the audio signal, the raw signal data, into text. And this is really useful because the computers cannot really deal with the signal as is. Unfortunately, we cannot do much with the signal as is. We'll have to transform it into a format that can be processed by the computer. That's why we do what we call, for example, transcription, transform voice to text, so we can manipulate the text and deal with the text, or here, transform transform the audio signal into digital format by extracting these features. So the process involves identifying the components of the audio signal that are good for identifying any linguistic content or any interesting patterns in there. What that means, what we want from the algorithms that help us extract features, or the methods that help us extract features, is to focus on the components that make the difference between different signals and ignore the noise. So we want to get rid of the background noise and only keep the meat or the core of the actual audio signal. One powerful method to do that is the MFCC algorithm, or the MFCC method. It's a powerful method. This has been invented, I believe, in 1980, and it's still used heavily until today. So more than 40 years now, 40 years ago, it was invented, and it's still heavily used. Some other algorithms are, for example, the LPC, the linear prediction coefficients, or the LPCC. But like I said, the MFCC is the most powerful one so far, at least according to my very limited knowledge. And I wanted to shed some light on deep learning techniques. So some architectures we have now are convolutional neural networks, so CNNs, or recurrent neural networks, RNNs, or long short-term memory networks, LSTMs, or the GRUs, or transformers. Transformers are making a lot of noise recently, so they're really powerful techniques. But in this presentation, we'll focus on CNNs. And to quickly introduce CNNs in one slide, we can never do justice to them in one slide. It's impossible. But generally, if you're familiar with the way normal neural networks work, so the ANNs, they do matrix multiplication a lot. And CNNs are just a clever variation of that. So they do what we call convolution in place of the general matrix multiplication in at least one of their layers. If you're familiar with image processing and image manipulation and image analysis, if you've used something like maybe Photoshop or PaintShop Pro, something like that, when you do blurring of the image, when you do edge detection, when you do corner detection and line detection and so on and so forth, what you're doing, you're applying convolution with kernels with fixed values. So some kernels have fixed value numbers, and the software tool multiplies the two matrices, or the image and that kernel or that filter, and then gives you the result. That's how you see the result. So convolution basically is a way of multiplying together two numeric matrices, generally of different sizes. So the matrices can have different sizes, but the dimensionality needs to be the same, meaning that if the image is 2D, then the kernel needs to be 2D. If the image is 3D, the kernel needs to be 3D, and so on and so forth. In CNNs, however, these kernels or these filters can be learned. So we learn these filters. We do not provide fixed values, but rather we learn them. So there's a lot more to it, but I'm going to stop here. You can contact me if you want to learn more about them, or if you want to find out more about CNNs. So a quick overview of some existing work. There's a really interesting article coming out from MIT, Massachusetts Institute of Technology. So this is a world-class research institute, and the article is titled COVID-19 Artificial Intelligence Diagnosis Using Only Cough Recordings. This is led by the expert I mentioned before when I said an expert confirms that the human ear cannot tell the difference between in the cough sound between someone who has COVID and not. This research is done by the same expert, so you can follow this link and access the paper. If you click or follow the link, it'll take you to IEEE Explore. I deliberately created these short links so they can be typed in instead of having long links, and then you can click on PDF and you'll have the full article. So this is a really interesting article, quite powerful. And here we have an effort from the University of Cambridge, again, world-class university, top researchers there. I personally know some of them, and they're really high-flying and clever people. What they're doing here is they've developed a smartphone app that can help them collect cough sounds. So if you visit the link, you can actually find this app in Apple's App Store or in Google Play. It's called COVID-19 Sounds. You can download it, and you can help them basically by coughing into the app and sending you cough. They're collecting data, and here they give you some details about the research they're doing. Okay, so these are two existing efforts which are quite interesting. And I wanted to mention quickly that it's quite easy actually. Once you've developed the model, it's really easy to develop a mobile phone app, a smartphone app that actually uses the model to make predictions, i.e. to do diagnosis. So once the deep learning model has been well trained, this is the difficult part actually, collecting the data, cleaning it up, extracting the features and building the model and training it and testing it and evaluating. This is the difficult part of it. But once the model is ready, once we are happy with the model, we know it performs well, we can host it on the cloud, for example on AWS, and then Again, it's not too hard to create what we call a language agnostic RESTful API based on the model, or that communicates with the model, so that we can communicate with it using any programming language. Language agnostic means you can communicate with it using any programming language. In fact, even using the command line or the terminal via using HTTP clients such as curl, if you've heard of it, curl, the curl command, or the curl tool, if you've heard of it. That's one useful tool that you can actually use. So once the model is hosted on the cloud and we've got the API up and running, then it becomes really easy. What we do is we record the sound and then send it to the model. The model can automatically extract the features using the MFCC and then feed them into the deep learning model, and the deep learning model can respond by sending us back the diagnosis. That's really it, once we've got the model, like I said, in a good condition or as accurate as possible. Any programming language can be used because the API is language agnostic, so it doesn't matter which language you use. And then developing a smartphone app to record the cough sound and then communicate with the model is not too difficult to actually develop. So this can be, for example, a graduation project, and I'm happy to assist with that if anyone wants me to, or if anyone wants to contact me, feel free to contact me and I should be able to help. So I wanted to summarize. We mentioned the fact that human voices can be used as an indicator of the health status in general, and it's possible to use deep learning techniques to accurately identify COVID-19 from the cough sound. So you record the sound, you extract features, and then you train a deep learning model, and then you have an unknown person with unknown diagnosis. You get the sound of their cough, extract the features, feed them to the model, and the model can give you a diagnosis. We mentioned it's really interesting that this can be much more accurate than the human diagnosis. Remember, we're talking about just the cough sound. This is because the human ears cannot identify the cough sound of an asymptomatic COVID patient, to be specific, and COVID patients in general. Also, we mentioned the fact that we have some powerful methods to extract features from audio signals, things like, for example, the MFCC technique. And these features can be used to train a deep learning model and maybe host it on the cloud, as we mentioned before. And a smartphone that implements the entire idea is not actually too difficult to develop once we have the model trained well and ready for predictions. I'd like to thank you very, very much for listening. Please feel free to contact me if you have any questions, and I'll try to join the conference live if I manage to do that. Thank you again, and I'll see you next time.